elevator is going to be super fun. Awesome. All right, well, good afternoon, everybody. I am so excited to be here today. As we get this talk started, I want to go over a couple numbers with you. I want to keep these two numbers in mind as we get started. The first number is 5,500. Now, in the grand scheme of life, 5,500 does not seem like that big. I mean, it's just, what, 5,500? But let's put some context to it. You see, AWS S3 supports up to 5,500 data retrieval calls per S3 bucket, per folder, per second. So that means that I can ask S3 to deliver to me up to 5,500 data objects for every S3 bucket, for every folder in those S3 buckets per second. And that is a much bigger number. The second number, 7,000. Again, not that big. But in 2016, Amazon.com announced that they were pushing over 7,000 code changes per day using their cloud technologies. It works out to about one change every 11.7 seconds, and that is a really big number. And the reason I bring these two numbers up is they illustrate the speed of business in 2019. Customers are demanding more features, faster responsiveness to their needs, and immediate access to their data, all for the same price they've always been paying. And so as we look at how applications are architected, especially in AWS, we need to understand that this is the canvas, this is the backdrop that our application developers and our architects are building these applications on. This customer demand for more features, more data, faster. Thankfully, companies like AWS and other cloud providers are letting us build and deploy code faster than we've ever done it before. They're deploying tons of tools and services that let us do one thing and one thing only: get highly performant code to production faster. But some architectures that we build with these tools can be abused. My name is Ryan Stalets, and for the next few minutes, I want to talk with you about two architectural features that can be used by attackers to hide command and control and expand their foothold in your environment. I want to set expectations up front. This is not a stunt hacking talk. The goal of this is to provide you with some fundamental knowledge about a couple problems that may exist in your environments back home, and use that information to go start a conversation with your cloud teams, your application teams, and build a relationship, just like Ian was encouraging us to do in that keynote this morning. Go take this information, build some relationships. To understand the importance and the impact of some of these architectures, we need to understand how many applications today are still built. In security, we are really fond of borders. Like, it's a big deal. What we've done with the cloud is we've taken the walled environment that we had in our on-prem data center and extended it out into our cloud environments. So we have an implicit expectation that any data, any code, anything that's entering and leaving our environments are going to be doing so through that network border that we've defined and through that security stack that we've defined, our firewalls, our proxies. Sometimes we find out, though, in the cloud that the border isn't exactly what it seems like. Sometimes we find out the border looks a little bit more like this, and we find out too late. When we deploy in the cloud, we have to understand cloud services can give unexpected ways around our borders, and we need to build that into our concepts of prevention, detection, and response. So let's move forward and talk about two ways this can happen. AWS S3 has been used for years to store static objects like files, videos, and pictures. Many applications that rely on S3 require very high bandwidth, low latency connectivity to their data in order to function properly. Back before 2015, if I wanted to use S3, my architecture looked something like this. My application had to egress out from my subnet. So this is an AWS environment. My application in AWS had to egress out from my subnet through the internet border, whatever border I defined. It then connected to the S3 APIs just from the internet, just like any other internet-based application. When we start touching the internet, though, two things are always true. Number one, we're going to increase our latency. And number two, we decrease the available bandwidth. And this kind of flies in the face of that demand that I need less latency and more bandwidth. So in 2015, AWS introduced a feature called VPC endpoints, and S3 was the first service on board. Now, with VPC endpoints, AWS puts an network interface inside my subnet. Traffic that is now destined for S3, instead of going out through my network border, will go to this network interface that sits inside my border instead. This effectively puts S3 inside my subnet and can greatly increase the performance of accessing S3. This is such a fundamental thing that this is actually part of the AWS well-architected framework. There are a ton of services that have VPC endpoints, and AWS encourages you to use them for this exact reason. So to recap, S3 endpoints let us access data storage, which is fast and infinite, without ever touching a security device, potentially. What can possibly go wrong with this situation? The answer is a fair bit, actually, because by default, S3 endpoints are not limited to communicating with just the buckets you own. You can communicate using an S3 endpoint with any bucket in that region owned by anybody, as long as you have access to it, as long as you have credentials or it's public or whatever. So just as easily as your application can pass dog memes back and forth to S3 as part of your application flow, an adversary can pass command and control traffic to and from S3 from behind your border, because S3 is basically just a glorified data storage mechanism, right? Just pass objects back and forth. This essentially bypasses any detection opportunities you expected to have on your border. So we can't decrypt this traffic and inspect it and look for command and control because it's going around our border, and then the attacker can get to that data from outside. And so that's the problem that we're faced when we deploy these types of endpoints. Using S3 for command and control is not really a new idea. I'm not presenting a new concept here. Rhino Labs actually wrote a Cobalt Strike module a couple years ago that does this exact thing. It uses S3 in order to pass these command and control objects. What they didn't fully explore in that, and what I don't think we've fully explored as an industry yet, is the idea of using these endpoints to bypass border detection and response appliances. I don't really think we've fully talked about that yet, and we really haven't fully seen the full impact yet. So by trade, I'm a blue team guy. I do threat detection and response. So I always like to look at things from that old SANS model, prevent, detect, response. So let's step through that for this architecture. So when I look at prevention here, we're going to find out as we go through this that an ounce of prevention is worth a pound of cure in this case, and we'll get to that more in a minute. But the good news here is that endpoint policies can be attached to S3 endpoints, just like bucket policies get attached to S3 buckets. It's not enabled by default. By default, these things are just implicit permit. They'll allow anything. But you can attach these endpoint policies. And what they allow you to do is they allow you to whitelist S3 buckets by name. And here we find the catch, because they allow you to whitelist S3 buckets by name. So this means no account level whitelisting, no organization level whitelisting. If you're a small organization and a small application, probably not a big deal, right? Your S3 buckets are probably fairly static. You're only working with one account. So it's not that big of a deal to maybe statically define the buckets you expect to access. But when you get into a large organization or large application, this becomes a monumentally bigger problem, because now I've got cross-account use, I've got even cross-organization use, my buckets are constantly in flux potentially. This creates a really big problem. The good news here is that automation can help us. It's all API calls, right? Automation can help us. So in the immortal words of every AWS product team ever, well, the customer can write a Lambda function. What I might suggest as a preventative measure for this is using a Lambda function on whatever schedule you want, 5 minutes, 10 minutes, an hour, a day, whatever, using whatever language you want, inventory the S3 buckets that you care about. Whether they're in your account or whether you have to go across to another account to inventory those, inventory your buckets. And then take that inventory and apply it in the form of an endpoint policy. This is going to enable you to essentially elastically grow and contract that endpoint policy while still enabling your application teams to use these endpoints and get the performance gains that they need. If your design has multiple accounts, you're doing cross-account stuff, you get into a little more work here, right? You have to not only keep track of what accounts you need to be inventorying, but also figure out how to get your cross-account access and do the inventories over there and everything else. but in my mind, the effort here is still worth it to achieve this prevention. In the department of detection, things are a little less rosy, because there's not a lot we can do on the network for this. VPC endpoints don't produce any kind of logs. They don't say like, hey, this instance connected to this bucket. They don't give me that level of detail. VPC flow logs give me net flow level detail, but it's net flow level detail. It's source IPs, destination IPs, session size, stuff like that. If I'm using these S3 endpoints, my application uses S3, I already know that flow is happening. You're not telling me anything new in these VPC flow logs. If you use the default, the AWS default DNS, the Route 53 internal resolvers, you don't have access to your logs, your query logs. If you don't use the default AWS DNS, you might have an opportunity here to get access to those query logs and find out when are we querying for buckets that we're not expecting to query. But if you do use Route 53, you don't get access to these logs. They do exist because guard duty has access to them, but guard duty today doesn't seem to have any finding types related to abnormal DNS queries. It just revolves around blacklists, like this is a known bad domain. They don't really do much yet with, hey, this is requesting things that are off baseline. We don't do much there yet. Maybe eventually they'll get to that, but not today. So now we have a really big task in front of us. We have to know that endpoint. Maybe our EDR tools can help here. Depending on how your EDR tool is hooked into the system, maybe you can see the DNS calls, or maybe you can see the HTTP calls, and you can know when things are off baseline then. But realistically here, when I look at this, that ounce of prevention is going to go a long way because we don't have a lot of detection opportunities right now. Talking about response. It is vitally important that we know when VPC endpoints are in use in an application when we respond in that environment. And just bear in mind, there are more than just S3 endpoints. There are a ton of AWS services that support this type of model. If we don't know this information and we move to containment, we can cause containment to fail silently, and we're still going to have an attacker with potentially access, at least back and forth command and control, into our environment. If you're in a response situation and you're looking at your endpoint and your endpoint activity does not align to what you're seeing on your border logs, even if nobody thinks, even if we're like, oh, there's no VPC endpoints here, look for VPC endpoints anyway. Just go into the account and look yourself. They're all under one tab. We have to understand that when we respond to applications in AWS, they are drastically different from traditional applications. It's my opinion that we need to be involving our application teams and our cloud teams so much earlier than maybe we're used to when it comes to responding to an incident. Once we have those teams engaged, we need to be asking good questions. Are VPC endpoints being used? How is your code deployed? And we'll get to more to that in a second because that gets important. How is the application designed? Gone are the days of just being able to respond to the infrastructure. We need to dive deeper into every application, every environment we have to do a response in. So moving forward, in order to understand our next architectural feature, we need to take a minute to talk a little bit more about DevOps. Don't worry, this is not going to be like a buzzword bingo talk. We're going to move past this. So DevOps is a really huge tool, and that goal we talked about earlier, to deliver features to our customers faster. The idea here is that we want to reduce the amount of time between a developer writing code and the end user receiving that code in the form of a patch, a bug fix, or a new feature. The thing here is that DevOps still emphasizes all of the traditional reviews that we would normally do. We still want to do our code review, we still want to do our analysis, we still want to do our tests, just like any other deployment. So then we get into the question of how am I going to take a process that normally takes weeks or months and turn it into days or even hours? And the answer, again, is automation. DevOps really demands that these processes be as automated as possible. We want to perform all of our static and dynamic analysis, all of our build tasks, our unit tests, and our deployment as automated as we possibly can. Many companies are going to choose to use AWS native tools to accomplish this. There are several native tools that help us build this tool chain. This really enables tight integration with AWS services, as you're going to see more in a second. So let's talk about the brain of this operation. Code pipeline is really the orchestration tool behind this all. It controls the flow of automation for your testing, your builds, and your deployments. The thing here is it's really flexible. You can mix and match different stages for however you want your application to flow. So for example, some flows might say you're going to build and you're going to do some tests and then you're going to deploy into QA. And then once you deploy it into QA, we're going to tear down QA and send it to prod once it's approved. You can build these flows however you want them to flow. Doing the legwork of getting this stuff out into the world is AWS Code Build and AWS Code Deploy. Now, these are two sister services, and their goal is to build your code according to whatever specification you define, and then deploy that code to servers, containers, or serverless environments. This is really what does the legwork of automating, getting your code out into your dev environments, QA environments, whatever the world is to you, these services are what get your code out there. Finally, CloudFormation. CloudFormation automates the provisioning of AWS resources. So the net effect of this is we can enable our applications to build and destroy their own infrastructure on demand. Gone are the days of cutting a ticket to a sysadmin who maybe in 3 weeks or a month builds a server, the server lives for 5 years, hopefully getting patched along the way, and then it dies. Application teams are now defining in their code, my application needs 3 servers to run, here's how I want those configured, and here's where I want them to live. Then as part of their deployment pipeline, that template goes to CloudFormation. CloudFormation automatically provisions this infrastructure for them. That infrastructure lives for as long as it needs to, and then when a new code revision comes out, ideally that infrastructure gets destroyed and the new code goes on a new infrastructure. This stuff can live for hours or days instead of years like we're used to. The idea here is they call it cattle, not pets. We need to treat our servers like cattle instead of pets. So this is how all this kind of fits together. I said code pipeline is the orchestration tool. It's the ringmaster of this. So depending on how you build your stages, your code is going to go to code build and code deploy, and code pipeline is going to send any templates over to CloudFormation to get built. We haven't talked yet too much about where the code comes from. We've talked about where the code goes, but we haven't talked about so much where it comes from. Well, code pipeline supports up to 4 different sources. It supports AWS Code Commit, which is AWS's implementation of Git, GitHub, which is the public Git that we all know and love, Amazon ECR, which is the Elastic Container Registry, Amazon's version of a Docker repo, and finally our old friend S3. If you're looking at this going, S3 is not a code repository, like one of these things is not like the other, you're not wrong. But here's the thing, not every organization uses one of these 3 services. A lot of organizations are going to be perfectly happy with their existing repositories, say their GitLabs or their Azure DevOps. They're perfectly happy with those, they want to keep those. With S3, I now get to build an architecture for this flow that looks like this. I update my code in GitLab through some integration that I have to write. That code gets dumped out into S3. And then code pipeline recognizes when there's new code to deploy, grabs that code, and then runs through the flow that you've defined. Here, though, we find the rub. Because with existing tools comes existing processes. It's really easy to assume in this architecture that if a deployment is in the bucket, then it's been through our test and release process. If we've been watching the news for about the last 10 years, we know that our industry is really, really bad at provisioning bucket security. What happens is a lot of times you're going to get an application that tells its cloud engineer, it says, I need S3 access. And we're not really going to dig into what access it needs. We're just going to say, oh, S3 access, there's a managed policy for that. And we just go attach the S3 full access managed policy because it's easy. But when we get into that, now we have other applications, other keys, other roles that don't need access to my super special code deployment bucket that now do. And now we end up with an architecture that looks a little bit like this. Because an attacker who obtains the correct credentials, and if we've over-provisioned, there may be a lot more of those credentials than you think. An attacker who gains credentials within your environment through either keys or an instance role or whatever can now push malicious code or templates into this bucket. Once that attacker has pushed their malicious code into your deployment package or their malicious template into your deployment package, code pipeline executes them as if it was you. It does not care who put it there. It only cares that it knows that there's new code to deploy and it knows what to do with the code. That's it. That's all we care about. The other thing we need to watch here is that with CloudFormation, when we're running these templates, they're going to run with whatever privileges in AWS we give it. So if we say we want to be the most flexible, let's let CloudFormation run as administrator so we don't have to come back and mop this up later. What you've essentially done is given an attacker who can push templates into this bucket administrative access into your AWS environment. Now they can build new access through maybe some IAM keys, maybe they can spin up some coin mining, maybe they can set up a server to proxy inside your environment. Whatever they need to do, they can build it now because they have access to this administrative role. So again, as is the way of our people, let's look at this from the perspective of prevent, detect, respond. So in the case of prevention, the key thing here is least privilege. And it goes beyond just least privilege and when I assign roles in IAM. In the bucket policies, we actually have the ability to define this thing called not principal. So normally we would define a principal that grants roles. We can say not principal here too. What we can do is deny all access to any roles or users that aren't one of the ones that I've defined. So for example, in this case, I've said Bob is the only one I want to have access to this. Everybody else is going to get denied, even if they're permitted by their IAM policy, denies trump permits every day. By the way, this is straight out, if you look up not principal on AWS bucket policy, not principal, this is a screenshot straight out of their docs. So like all this is documented. And that actually is really important. Go Google this before you do it. The thing is that when you start assigning privileges like this, and especially when you're like denying star, you have the potential to lock yourself out of your bucket. And that's really bad, and it gets really hard for support to fix. So don't do that. Definitely read up on this before you deploy it. Don't just kind of, hey, we're going to do this in prod tonight. But make sure you read up. So on detection, the idea is just like we want to lock down these buckets hard, we want to monitor them hard. Using CloudTrail, we can actually monitor for manipulation of data inside these buckets. The problem is that by default, CloudTrail does not include S3 object logs as part of its package. You get management plane logs, but you don't get, they call them data events. You have to go in and configure this separately, and you pay a little bit more for them, but my suggestion is that it's worth it. Once we've enabled that, now we can investigate any data manipulation in this sensitive bucket, in this pipeline bucket. So now I can go, okay, this role that is not my pipeline role is putting new data into this bucket, or is downloading data from this bucket, or maybe it listed the objects in the bucket, whatever. Why is something that isn't my pipeline role touching this bucket? Why are we doing it? Tools like Elasticsearch and Splunk get really handy here because you can start to slice and dice the data different ways. I like Elasticsearch. There are Splunk shops out there too, but failures here are also really interesting. It's really easy for us to think that, oh, it failed, they weren't able to get the data, or they weren't able to put the data, so like, who cares that they got denied, especially when this bucket's locked down super hard. But failures can also tell us that something else bad is going on. For example, why do I have a developer even trying to mess with this bucket? Or why are these keys that should never touch this touching this? Just because something failed doesn't mean so either somebody's not doing something they're not supposed to do, or that we don't have compromised credentials anyways. And so those are still really interesting to look at. Finally, moving forward into response. This is where we get to the point where we have to consider infection sources beyond just our traditional exploits. Remember how I said earlier, we need to ask our application teams, how is your code deployed into your environment? We really need to understand how this code's actually getting deployed, because we can compromise an S3 bucket. It's probably easier, but like repositories can get compromised too. We can just start chucking code into repositories too. So we need to understand how code and how templates are actually being delivered into our environment. We need to remember that we need to include pipelines in our containment. When we take our containment actions, we have to make sure that we're cutting off the flow of new code and new infrastructure into our environment. And finally, if we do have a compromised pipeline, we need to make sure that we include that in our eradication and recovery efforts. Otherwise, we're going to continue to have a compromised account, especially when the next deployment goes through and we just end up with more compromised code. So in closing, I want to leave you with this call to action. Take the concepts that I've presented here today and have a conversation with your application teams and your cloud teams about these issues. This is only two of 100 or maybe thousands of different issues that you're going to run into as time goes on. This is only going to get worse, or it's only going to continue to progress, right? let's use this as an opportunity to build a relationship. Let's just not say, well, I saw at a conference that these architectures have problems, so no, you can't do that. Please don't do that. This is a very high-level overview of a complicated topic. Use this information to go build a relationship, have a conversation, so that we're more prepared to prevent, to detect threats, and to respond to those threats in the future. Thank you guys all for coming today. I love to talk to people. So like, if you want to shoot me an email or hit me up on Twitter or whatever, I'm more than happy to talk with you about this. This will be on YouTube later too. If you have questions, I have a few minutes for those now. So with that, who has the first question? Bueller? Bueller? Shoot.
On the prevent, initially, when you talk about you are using the inventory number to go against endpoint policy,
Yep.
you would like mention your endpoint policy by number of endpoints you have against.
Yeah, so the question was, when we use the inventory, are we basically comparing a number? How are we doing that? It's not a number inventory. It's not a how many buckets do I have. It's what are the names of my buckets. So once I've done like a list all my buckets API call, now I can take all those buckets, I can programmatically build a JSON object for my endpoint policy, and I can push that to my endpoint via the API. So it's not a count, it's a these are my buckets kind of inventory.
So you program those bucket names into the endpoint policy?
Yes. It is, well, for loops are a thing, right? So like you, with the AWS API, you can extract a list of all the buckets that you own in your account, and then you just basically take that list and throw it into the JSON object. So what else we got? Mm-hmm.
What do you mean by I mean, know what you mean by EDR, but what do you mean by EDR?
So the question was, what do I mean when I say EDR when I come to detection? EDR is endpoint detection and response. So these are going to be like your Carbon Blacks, your Taniums, Red Canary, I think has one maybe. These are going to be your endpoint tools that are focused on visibility for incident responders and threat detection folks. So, and that's going to live on the endpoint, on the server, on whatever. Anybody else? All right, well, I'm going to be around for the duration, and I'm going to hang out here for a few. So if you run into me, please walk up and talk to me. I don't bite, I promise. Thank you.